I think I might have started too early. Welcome to the third day of ISART. We really hope that everybody's enjoying the conference so far, especially given that we're trying to come as close as possible to a face-to-face experience, given the situation I think we're all in. So we appreciate your patience and your participation. Today we have two segments that we're going to cover. The first is covering the technical side and policy aspects of securing and making more resilient the technical side of 5G system during the deployment process. And the second is how monitoring and data collection can and should improve the valuable input and feedback into the design, deployment, and operations to improve the resiliency of the same network. Please note, FCC auctions 105 and 904 are ongoing. As such, participants in the meeting may be subject to the FCC's strict anti-collusion rules. So accordingly, during these discussions, there can be no disclosure either directly or indirectly of any of the company's auction bids or bidding strategy or post-market auction structure. Post-auction market structure. So some logistics. Our virtual ISART 2020, as you know, is structured into two 2-hour blocks each day. The organizing committee has worked hard to find ways to incorporate the tools for the real-time interaction among the panelists with in-depth plenary talks, highly interactive Q&A, and opportunities for networking and conversation in the breakout rooms. Please feel free to ask questions online during the presentation and panels. Remember to spell out any acronyms, please. Also, look at the questions already in the Q&A section on the right side of your screen, and please vote if you'd like to hear an answer to a particular question. The moderators will work hard to pull questions based on the interest level, and we'll also work to try to take the unanswered questions into the breakout room so that everybody has an opportunity to hear an answer to their question. The last half hour of each 2-hour block is reserved for those breakout rooms. We hope the breakout rooms. Basically, what we're trying to do is we're trying to build the same experience that you'd get if you could go chat with the panelists during a coffee break. So kind of keep that in mind. We're really looking for a kind of casual interaction there. So as I said, after each panel concludes, the panelists and speakers from that session will exit the BlueJeans events platform and head over to the BlueJeans meetings platform for their breakout room. I'm reading Melissa's notes yesterday, and she says fingers crossed. So there you go, Melissa, my fingers crossed. For those of you able to download and access the brand new ISART app, we encourage you to do that. All the information and links needed for the breakout rooms are in the app. For the non-app users, the ISART confirmation email sent this last Friday has quick links that contain the link and the phone number for the breakout room. Room hosts from the conference will be there to help if needed. So if you run into any kind of problems, reach out to the conference services staff listed in your confirmation email. Quick technical note. The code to access the main sessions on the BlueJeans event platform is the same each day. So if you do have issues with the link, please try the next comparable link. And also, again, the ISART app will also allow you to reach out and connect with each other. By default, the only information that anyone will see on the app is your name and affiliation. So if you're open to chatting with others, networking, exchanging virtual business cards, please remember to go into the app and add whatever information you think is relevant. Again, we encourage you all to use those interactive tools to ask questions and talk with your panelists and presenters in the breakout rooms, because again, we're trying the best that we can to replicate that face-to-face experience for you. So with that, I'd like to introduce our first speaker, Professor Alenka Zajic from Georgia Tech, where she's the professor in the School of Electrical and Computer Engineering. The professor has completed her BS and MS degrees from the University of Belgrade and her PhD in Electrical and Computer Engineering with Georgia Tech. Her research interests span electromagnetics, wireless communications, and computer engineering. Professor Zajic is going to give us a high-level overview of supply chain verification problems and possible solutions offered by EM side channels, including RF detection of malware. Please remember that you can submit questions during the presentation, and if there's time remaining after Professor Zajic finishes, then we'll see if we can't work through some of those questions. And so now I'll turn this over to our first speaker, Professor Zajic.
Thank you, Andrew, for the introductions. Hear me?
Yes.
Hopefully you can.
Yes.
All right. So I want to bring attention to side channels, analog side channels in particular, and how they can help us with supply chain protection and verification. So next slide. When we say supply chain protection and verification, it implies different things to different people. So what I want to bring together is verification of the hardware. And this is one example of allegedly China using a tiny chip to infiltrate motherboard of the server. and us. So that's one of the things we want to check against. And the problem is that when you get a fully finalized board and it has so many components, how do you look for the intrusion? Slide 3. The second problem is firmware verification. That is the software that is activated when you are booting the system, and every phone has it, every computer has it, every equipment that you are using in the power plant has some sort of booting software that says, hey, okay, this is what we are supposed to do. And currently, that is not verified in any way. Slide 4. And the fourth problem is obviously intrusion of the malware or any other intrusion that happens over the network. And this is one example of how the ports were crippled by the malware that took over their network in under 1 minute. So how do we solve all three problems together? So the next slide. Well, we propose to use side channels, and the side channel is a means of obtaining information about the software execution outside of the program intended communication. Next. So what does it mean? Can you click all of them? Thank you. Oh, that's good. So what is a side channel? It boils down to you were not supposed to consider X as a source of information, and that's what I will refer as a YWNS. The next slide, 6. So the side channels can be timing side channels where you can obtain information about the performance of the code by observing how long something took to execute. It can be cache side channels, where you're looking at the microarchitecture, try to deduce something about program execution. And there are analog side channels, and they can be power, EM, acoustics. You will see the new side channel we found out, we call it backscattering or impedance side channel. They can tell you a lot about physical aspects of the implementation. And then you can use the bus snooping or DRAM freezing if you are allowed to open the system that you are observing. Next, 7th slide. And you can click all of them. So the Bell Labs discovered first wireless side channels in 1943. So they have been around for a long time, and they discovered it by building the telegraph. They told military it's perfectly secured. And while testing it, they realized that on the other side of the room, on the oscilloscope, they can see the some activity that is related to the messages they are sending, and they dig deeper into that and found out that they can actually decode the message. And when they told it to military, they said, "Oh, we don't believe you." So they actually put them in 2 different buildings, and they were able to reconstruct the message. And what happened is they put a tempest on it, said, "Let's never talk about it," and it has been like that for a long time. And then they popped up again in the cryptography community around 1980s, where the concern was about reconstructing private public key encryption, and that can be broken via side channels. And the side channels are very well known in this community for a very long time. And they were mostly focusing on the hardware such as the microcontrollers that are usually in your credit cards that you're using on a gas pump and things like that, where they really don't want to you to get exposed. Slide 8. So about 10 years ago, we started looking into this problem, and where the starting point was, can you get any emanations from the modern systems, like laptops, desktops, cell phones, IoT, and so on? And can you extract any interesting information, and how far away you can do that? Those were the first questions Miloš Prvulović and I tried to answer when we started looking into side channels. The other questions we tried to answer is what is physically driving this behavior, and how it can be used in various ways. So it turns out is that yes, laptops, desktops are complex, but information still can be extracted, and it can be extracted from the significant distance. So collecting all this knowledge over 10 years, what we proposed is that we can help supply chain verification in 3 steps. On the left side, you have this called RFB analysis, which means RF backscattering analysis, that we use for the hardware Trojan detection. Then we are using EME analysis for the firmware verification. And then we can also use the EME analysis for the real-time monitoring of the system in the field. And today I will talk about a little bit about all three parts and how side channels can be used for that. Slide 10. So let's start with the RFB analysis. So hardware Trojans are particularly nasty because they're tiny and they're usually not activated until a certain event happens, which means you need to find them, either you know the combination how to trigger the behavior, or when it's triggered you can detect it, but it might be too late because your drone is going down. So power, EM, acoustic side channels, they all depend on the current that needs to go through the circuit, which means circuit has to be activated in order to find it. And what we said, like, oh, what if I look for the impedance? That's something that doesn't have to be active and it's always attached there. So how do you get the information about impedance? Well, you use the backscattering. You send the unmodulated signal, and the state of the inverter usually has the two different impedance states. They're tiny differences, but turns out when you have a lot of transistors, you can actually detect them, and the modulated signals comes back, and that way we can tell that something additional got attached to your original circuit, and that way we try to detect the hardware Trojans. Slide 11. So we looked at the AES crypto processor on FPGA. We looked at the Trojans that are in a trust hub that everybody looks at, where the size of the Trojan is about 1.7% of AES circuit, and so on. And we try to detect those. Slide 12. So what is the idea here? The idea is that Trojan's trigger circuitry is small, but always active. It's much, much smaller than overall Trojan. And that Trojan connections to AES circuits changes impedances to the original circuit. Hence, we might be able to detect that through the backscattering. Slide 13. Oh, there's more on this slide. What we are trying to detect is a sub-cycle temporal granularity, which means you have a really fast clock, and within that clock, some things change. And for that to detect, you really need a large bandwidth that can observe many times the clock rate of the capture change. And by looking things in the frequency domain, we actually look at the harmonics of the clock and are able to detect that. 13 slide. So this is the picture of how we would measure it. We are using the electric probe to inject the sinusoidal signal, and then we are using the magnetic probe to collect the signal so that we don't have interference between the two signals. Slide 14. And this slide, what I want to show you is how much backscattering performs better than EM and the power. And we are detecting both dormant and activated hardware Trojans. And you can see that the green line of the power and the dormant performs the weakest. Then EM performs a little bit better, but it still has a lot of false positives, while the backscattering can detect both dormant and activated with 100% accuracy. And the reason is really that we are detecting is something physically attached to it or not, and we don't need the currents flowing through it, which helps a lot solve this problem. We can detect down to 32 gates, just the trigger part of the Trojan, which means we can detect really, really tiny changes. Slide 15. We can also detect the counterfeit designs, which means if the layout changed in any way, but the components are the same, we can also detect that with a really high confidence. Slide 16. So that was the RFB analysis for testing the hardware Trojans. You can do that once when the manufacturing is done, it arrives to your system, and you can do this XYZ positioning and find things. People would say like, oh, but you need a golden example for that. Yes, and we're working on solving that problem without a golden example. One way is the modeling of these impedances, and the other one that we came up with is I can measure a large number of boards and actually cluster them into two groups of infected versus uninfected. I may not know which one is which, but I can destroy only two boards and actually do reverse engineering that way and figure out what's going on. So there are ways to solve the problem of not having a golden example. So let's talk about now firmware verification. Slide 17. So this is an example of the system SCL351S, which is often used for power systems. Actually, in many military systems it is used. And here you have a huge metal box, and you want to verify is the firmware correct. And what we discovered in testing many of these SCL boxes is that actually firmware changes without anybody notifying you. On the right side, I'm showing you the spectrum of the firmware, and these lines that you're seeing here are actually the loops in the code. So even if the hardware is different, I can still say this is the effect of the software, not of the hardware. Slide 18. And here we're showing you different firmwares on the same SCL box, and the results show that you can classify them, and actually you can visually say that the spectrograms of these three devices are different. So these side channels can be used for protection of the firmware system. Slide 19. And the last piece is the EM-based software verification in the real time. Slide 20. The key problem here is how quickly I can detect that my network is under attack. Here we're showing the medical device, syringe pump, again, something that is hard to monitor in traditional ways. Slide 21. Slide 21. Where basically we're showing the spectrogram on the left side of normal behavior, and then on the right side, it's when it's attacked. And we're showing also the fact of they have a very specific features that are different than when the malware is actually attacked. And to make a point here, we are actually reusing the same code, and we change the things only into instructions. So these are very, very tiny changes that we are we can easily detect. Slide 22. Here we are testing it on various devices, typically IoT devices, and we are showing the detection of latency, and they're all under 1.5 milliseconds, and we have 0 false positives and 100% accuracy. So this is a very, very efficient way of detecting things. Now, if you go to slide 23, I want to show you the spectrogram. On the left side, you have a DDoS attack like Mirai, and on the right side, you have a ransomware, and on top of that, you have a context switching between the ransomware and the application we want to run. And visually, you can detect them. They're really large changes. So the things that are really hard to detect on the network level because they're tiny, here, when they start being executed on the processor, they're very easy to observe using side channels. Slide 24. Okay. So to conclude, analog side channels are not always bad, and understanding physics behind it really can make it as a powerful tool. They are new side channels to be discovered, and leveraging them for a firmware verification, malware intrusion, hardware Trojan detection is very, very powerful tool, and I have other applications where the side channels can be used. Slide 25. I want to thank you for listening, and thank you, government, for funding this research. So I'm open for questions.
Thank you very much for that, Professor. I appreciate that. Let's see. Let me go to my special Q&A thing here and see if we have any questions. I have one. It is, can you discuss countermeasures to side channel monitoring, such as random emission generation?
The main problem with like if you want to really fight the side channels, you need to use asynchronous circuits because as long as things are clocked and using the same power plane, there will be side channels. So you would need to make every circuit have their own power source and being clocked with the different ways and with a different timing and so on. And as you can imagine, that is a very expensive way of doing things. The other way is to fight emanations by reducing emissions in the first place, making voltage regulators more quiet or the processor clocks more quiet, spending less power and stuff like that.
Okay, thank you very much. Refreshing my question poll again. Does anybody else have any questions for Professor Zajic? I'm not seeing any come in. Thank you, Professor. I really appreciate that. Okay, I don't think we have any more questions. So I think what we'll probably do is we can switch over and prepare for the next panel. So again, thank you very much. I appreciate it. Okay, so our next panel is a great collection of different backgrounds and skill sets. It's going to dive into both the technical and policy sides of 5G while looking at zero trust through the lens of deployment and government. Our panel moderator is Drew Morin. Drew Morin currently serves as the Director, Federal Cybersecurity Technology and Engineering Programs for T-Mobile. He's responsible for identifying emerging and cybersecurity trends and regulatory policies to improve security programs. Also, please keep in mind that the slides will be available in a few days and recordings in a couple of weeks. And so now I'm going to go ahead and turn this over to our moderator for the first panel of the day, Drew Morin. Thank you.
Hope everybody can hear me fine. So starting off today, I wanted to just basically, first of all, thank you all for coming in to see what we have to present today. We're very excited. We have a great set of panelists here to cover this topic. We're going to cover from a broad perspective. So I'm going to kind of jump right on into it and just start with a few opening comments, and then each one of our panelists will have some opening comments as we go. And then in the back end, we'll take questions and we'll discuss as we proceed. So first of all, I wanted to just kind of note that when we take a look at what we're dealing with here, as a carrier, we obviously dealing a lot with licensed spectrum. And spectrum itself, I mean, is just basically a bunch of frequencies, but a licensed spectrum represents an exclusive right to use a set of frequencies. And of course, that's going to be subject to interference, power levels, and other types of constraints. So the objective for us is to minimize the potential for interference between different spectrum allocations. That's to help ensure the availability and optimal use of spectrum bands. It's also one of the things that we do to ensure that we're monitoring what's going on in the spectrum so that we can identify other potential interference and work with industry and government partners to mitigate those types of threats. There's also non-exclusive spectrum allocations, the idea of shared spectrum. And they have a slightly different set of rules of the road. I'm not going to go into that in much detail. Some of our other panelists may want to cover some of that more information. But the unique challenges they're going to represent is things around the allocation of the shared spectrum. Once again, there's interference and the ability to release spectrum up for others to use when you're sharing it. So there's a lot of technical challenges around that type of spectrum as well. When we look at 5G and when we're deploying 5G right now, one of the key factors we're taking into account is that 5G expands the amount of bands that are available and how they're going to be applied, and really how they're going to be applied to support additional use cases. Not every use case works with every band efficiently. So when we start going through that, we start looking at how we're going to deploy the spectrum, we want to ensure that we're taking into account a lot of the different aspects of threat. And specifically, we're looking at things like a jamming threat, the idea of rogue base stations, even the physical attack on a cell site, as well as looking at things like supply chains we just heard about. Those types of our equipment and firmware can come into the radio side of things in the radio access network, and they can cause additional potential avenues and vulnerabilities and threats. So we're going to talk about a lot of different perspectives related to what we mean when we're talking about the resilience and the security in a 5G deployment. And we're going to be talking, as Andy said, about policy side as well as about the actual technology involved with this. So what I wanted to start with is to basically identify that our speakers, we've got folks who are basically, we have equipment OEMs, we have wireless carriers, we have industry associates, and we have government policymakers here. So this diversity of opinion is really going to hopefully help to paint a broad overview of the challenges and what has been done and what is being done, and hopefully identify for you all some areas where, from a spectrum perspective, there may be opportunities for forward-looking research. We'll be talking a little bit, hopefully, about some of those things as well. So I want to open the discussion describing some of the work that T-Mobile, in partnership with industry, in partnership with government, and with academia, that we've pursued specific to various threats to the 5G networks. Many of these activities that we're associated with are primary security resilience or further up the stack than typically the RF side and the data link layers. Examples of that are supply chain risk management. And that's where you're talking about the overall ecosystem and how you're going to be able to mitigate 5G threats to the components and provide assurance to the components that are actually deployed within the network. Some of the examples of what we're doing today in supply chain risk management is in partnership with ADIS and the Department of Defense. We are co-chairing a working group that's looking at assured 5G as an example. We also work with our industry and government partners and the Department of Homeland Security on the Information Communications Task Force for Supply Chain Risk Management. There we're looking at everything from information threat sharing to actually threat evaluation and other types of policy and technology actions associated with identifying suppliers and products and services and how to evaluate those risks to improve the overall supply chain ecosystem. Finally, the industry and government, we also are represented in various CISRIC working groups. And CISRIC is the Cybersecurity, Resilience, and Interoperability Council working groups that are hosted by the FCC and focusing on 5G. I think it's important that we know.
Hi, Drew. Drew, I think your audio has dropped.
Hey, Drew, can you see me? I think your audio has cut out, so we can't hear you. Can you try? Speak again?
I can hear you now.
Okay,
Yes.
we can hear you. Okay. Yeah, we got you. We got you back.
Okay, so my mouth was moving and nothing was coming out. That's standard fare, I guess. Okay, so I can tell from Anita that I am still being heard. Okay, so I'm assuming that I was talking a little bit about the CISRIC when I blanked out. Just basically, CISRIC is a partnership between government agencies and industry to look at emerging trends and to try to get ahead of it and identify different ways of dealing with the resiliency and the interoperability of these networks. And one of the things we're working on in the current CISRIC, in both the non-standalone as well as standalone deployments, is there's a lot of focus on what I would call the data link, which is that connection, that authentication and connectivity that happens at the radio access network to the user equipment. So that's one of those areas where we are working as a public-private partnership to identify where those threats are, what are the mitigations, some of the things that are built into the specifications and standards, and how we can improve that overall experience and overall resilience of the network going forward. Now I want to drop into a couple other things that T-Mobile is doing specifically in 5G threats and mitigation. And one of those areas is the rogue base station. The idea of putting up a cell site that's an artificial cell site with the purpose of impersonating legitimate cell towers to intercept traffic for some kind of nefarious purposes, whether it's to compromise privacy information, to insert malware on devices, and other types of bad actor activities, if you will. One of the things that we did in partnership with the University of Washington and the Department of Homeland Security under the National Infrastructure Protection Plan, Security and Resilience Challenge, is we proposed and executed a research project focused on capturing network and event logs, including control, authentication, and attachment data between the UEA and the base station, the UE being the user equipment. The objective here was to look at this flow of data, capture the legitimate traffic, and also capture how a rogue base station would operate, and see if there are signatures we could identify and develop to basically create an algorithm for detection of rogue base stations. That research paper I'll make sure is available for you post-show to be able to look at, and it may be an area where some of the researchers here might be interested in pursuing additional activities in that area. Rogue base stations are a continuing threat to the attachment and the security of networks. And we need to continue to, if you will, it's almost like spy versus spy. We need to continue to improve our ability to detect and mitigate those quickly in the network. Another area of public-private partnership is the current ongoing work at ADIS around wireless emergency alert. And this was actually a WIA exploit, was uncovered by University of Colorado researchers. And they brought this up wrote up a research paper on it. The FCC convened a workshop with participants from industry and from academia to discuss this vulnerability and develop an action plan for mitigation. A working group was established in ADIS, and it has been working towards addressing the potential risks around this vulnerability with a report expected to come out by the end of this year. So those are some of the examples of where T-Mobile, as well as industry, public-private partnerships have been executing to try and address threats and vulnerabilities within the wireless environment, specifically most of them around the RAN side of things. So I hope that gives you a little bit of a baseline of some of the activities we have going on. Now, wrapping up my opening comments, I anticipate you're going to see today that the vulnerabilities in the RF domain definitely an area of emerging focus and represents a tremendous opportunity for continued research to improve the security and resilience of this emerging network, especially these emerging network generations beyond 5G, as we become more dependent on this wireless connectivity and the ability of these networks to touch our lives continuously all around the world. So with that, I'm going to turn it over and introduce our first panelist. Jaisha Wray is the Associate Administrator for International Affairs in the Department of Commerce's National Telecommunications and Information Administration. In this role, she formulates telecommunications and information policies and promotes these in international fora. Jaisha will lead off our discussion on policy by addressing the following questions. What has the administration's approach been on ensuring secure and resilient 5G networks, and how is the administration working with industry and international partners on these efforts? Jaisha, turn it over to you, please.
Great. Thank you for that introduction, Drew. I am very pleased to be able to join you all for discussion on a key area of focus for this administration, securing the supply chain and infrastructure for 5G in the United States. Today, I will provide a high-level overview of the U.S. policy efforts that underpin the implementation of secure and resilient technical solutions, which I'm hoping will set the scene for the discussion with the carriers later in the panel. I'm also going to discuss some of the areas of cooperation with both industry and our international partners. Now, in my last position, I worked on 5G policy and cyber cooperation on the National Security Council staff. And I was lucky that my time there overlapped with Anita Patankar-Stoll, who you'll be hearing from next on this panel. Now, while on the NSC, Anita and I worked on the development of the National Strategy to Secure 5G, which was signed in March of this year. And as Doug Kinkoff discussed during his opening remarks on Monday, this strategy serves as our overarching strategy for the security of next-generation wireless communication systems and infrastructure. And it frames how the United States will secure 5G infrastructure at home and abroad. The strategy outlines how the United States will facilitate the domestic 5G rollout, assess and address 5G security risks, and promote responsible development and deployment of 5G infrastructure globally. It also outlines how the United States will continue to work with our partners and allies to lead the global industry as 5G standards, technology, and applications evolve. NTIA is working closely with the National Security Council and a range of other departments and agencies to develop an implementation plan to ensure that the goals of the national strategy are met. Now, there are also a number of complementary presidential and legislative actions that represent a holistic, multifaceted approach by the administration and by Congress to work to ensure secure and resilient 5G networks. I'll go over some of those examples now. One example is the Federal Acquisition Supply Chain Security Act of 2018, which creates a unified, whole-of-government approach to protecting federal systems from supply chain risks. It established the Federal Acquisition Security Council, or the FASC, and it enables government-wide exclusions or removals of specific products determined to pose unacceptable risk. Another example is Section 889 of the 2019 National Defense Authorization Act, which prohibits federal agencies from procuring or contracting equipment or services using telecommunications equipment from 5 covered Chinese companies. And as of August 13th, 2020, which is tomorrow, it will prohibit federal agencies from contracting with any entity using such covered equipment or services as a substantial component of any system. Another example is the Secure and Trusted Communication Networks Act of 2019, which prohibits certain federal subsidies from being used to purchase communications equipment or services posing national security risks. It also provides for the establishment of a reimbursement program for the replacement of communications equipment or services posing such risks. And my colleague from the FCC will be discussing this act in further detail later on in the panel. In addition, in May of 2019, the President signed an executive order on securing the information and communications technology and services supply chain, or the Supply Chain Executive Order. Now, this executive order will prevent foreign adversaries from exploiting vulnerabilities in the ICT supply chain and protect the vast amount of sensitive information being stored in and communicated through the ICT products and services. And then finally, in April 2020, the President approved an executive order formalizing Team Telecom, a committee that assesses foreign participation in U.S. telecommunications and assists the FCC in its public interest review of license applications. The committee also reviews applications and licenses for risks to national security and law enforcement. Now, given how interconnected our networks are and will be with 5G, the USG understands that we cannot undertake these efforts to secure our 5G networks alone. NTIA continues to work hand in hand with industry to secure our networks. This is why NTIA launched the Communications Supply Chain Security Risk Information Partnership, or CSCRIPT, which is a program to share supply chain risk information with trusted providers and suppliers of communication services and equipment. Now, this program will focus on small and rural companies that may not normally have access to this information. NTIA is also working directly with industry players on adding transparency to the software supply chain by helping those who write, purchase, or operate software to understand potential risks in the software supply chain. So when a new vulnerability or risk is discovered, a software bill of materials can help any organization realize whether they or their customers might be at risk. Our international partners are also critical to this effort, particularly as we look to promote vendor diversity in order to reduce or eliminate reliance on untrusted vendor equipment. We are seeking to enhance vendor diversity by accelerating the research, development, and deployment of open interfaced, standards-based, and interoperable 5G networks across the country. Through international cooperation, we believe we can accelerate the global transition towards an open 5G network architecture and build a diverse 5G ecosystem. So these activities are just a few examples of the administration's efforts. We will continue to work closely with our international partners and industry to ensure 5G services can be accessed both safely and securely. Thank you very much, and I look forward to the discussion.
Thank you, Jaisha. That's a lot going on there. That's a lot for us to take in. So I hope everybody captured all that information. I certainly was typing like a crazy man. So next I'd like to introduce Anita Patankar-Stoll. She's with Verizon. She serves as the Public Sector Counsel in Verizon's business group, Public Policy, Law, and Security. In this role, she supports the public sector compliance in various areas, including supply chain risk management, cybersecurity, Universal Service Fund, and program implementation. Anita, will we consider the anticipated meteoric growth of IoT that will be facilitated by these 5G deployments? Would you be able to comment on some of the issues this may cause and possible mitigation strategies around that? And as well, not only the technical issues, but are there possible policy considerations for government to weigh in that could be impactful in a positive way for these 5G deployments? If you could address those, I'd appreciate it.
Great, thank you so much, Drew. Thanks for the opportunity to sit on this panel with my esteemed colleagues, and I have to say thank you to Jaisha for the call out. I am recently left government, and I'm recently with Verizon, so now I get to see sort of how industry takes a look and tries to implement policies and works hand in hand with government. So Drew, this question that we've posed here is a huge one, and of course we could take hours talking about it. So I'm going to focus here my comments on sort of spectrum issues around it, but obviously there's a whole discussion around IoT and cybersecurity and some of the things you mentioned in your opening remarks about authentication and that sort of thing. So just looking at the spectrum and looking at that RF link to make sure that it is in fact secure, and that sort of implementation is occurring. The 5G world really does provide us with a new and exciting world of things that we can employ, like dynamic spectrum sharing, for example, is one of those, which will allow us to effectively and accurately and reliably coordinate the Gs, the 5G and 4G spectrums that carriers have. I think that's one of the ways that spectrum management will continue to change and evolve. We've basically gone from manual efforts to automated, and hopefully now to dynamic. These new efforts can really are exciting because they can automatically shift lanes in the road as needed and leverage the spectrum and enhance consumer experience. I think there's just going to be a massive number of devices that do different things. Some IoT devices will do very little networking. Other devices will do more complex solutions like AR, VR that require massive computing capabilities on the edge of the network. So we have a challenge. Operators have a challenge to sort of right size their network resources for the various use cases that we will have in the coming future. We also can think creatively about ways to leverage licensed and unlicensed spectrum in a way that doesn't cause interference to the licensed spectrum use. I think it's really a critical time for industry and policymakers to collaborate to ensure that the explosion of IoT use and new uses in bands doesn't cause new sources of interference to the established regimes that we have. Of course, from a technical side, there have been and will be operators will continue to use technical methods to deal with in-band and out of band interference issues. So we have everything from, considering distance, frequency separation, using filtering, using case restrictions for the bands at issue. All of those will continue. So from 4G to 5G, there's a lot of making sure that we've learned from what we've done before and continuing down the same path. Operators will continue to resolve interference issues. We have thousands in my new place of employment of cybersecurity professionals and employees and engineers who are monitoring our networks to identify and respond to threats. We get regular reporting about the data, about the reporting and data about the network. Engineers can look at patterns of interference and closely monitor call and data process failure rates. They can look at the frequency bands and the type of impact that is occurring and draw conclusions. We can keep track of products that are known to cause interference issues. Alternatively, of course, we are in hurricane season, and nature could be the cause. And so there's a lot of analysis that goes on and will continue to go on. This, of course, can pose challenges depending on the size of an operator. And I think my colleague on the panel, Carri, will probably give us some insight into sort of what rural providers are faced with. And so it may be that some carriers really do rely on customers to notify them that services is degrading or calls aren't going through, that sort of thing. So we have to work with all of that. And of course, if interference is particularly bad, then operators, of course, will utilize the FCC's Enforcement Bureau. This is actually where I started in FCC ZB, and go to them for assistance. Of course, under the Communications Act, Section 333, which states no person shall willfully or maliciously interfere with or cause interference to any radio communications of any station licensed or authorized under this chapter. Of course, there are a number of ways the FCC can act to address interference issues. There's a number of regulations around marketing radio frequency devices prior to equipment authorization, and dealing with devices that need to be certified by a telecommunications certification body. And so all of that will continue to go on. I think that, in the future, turning to your question of what can policy makers keep in mind, I think we continue to need good policies that are driven by technology and advances. We don't want dirty devices deployed in the US. So device certification may be an area where we have to start thinking a little creatively. I think the first presentation from the professor I was taking notes, very interesting, thinking about software, thinking about how software can change the operation of devices and cause a device that didn't cause interference before to now start causing devices. Actually, the FCCZB had issued an advisory in 2019 about devices containing that should contain security features to protect against modification by unauthorized parties. But then the question in my mind becomes, what happens when software is used and is deployed by an authorized party and somehow it inadvertently causes the device to operate in a manner inconsistent with the device's equipment authorization? It's kind of a new world of dynamic change, and how do we grapple with that both on the government and industry? I think policymakers should continue to work with large retailers to make sure that devices aren't permitted to work and sold here in the U.S. So Part 15 devices have their challenges. I can go online right now and buy some devices that shouldn't be used in the U.S. We hear, of course, a lot of challenges in the sort of old days, right, with baby monitors and badly placed routers and microwave ovens. But I think there's going to be, we achieved, worked on that well in the past. We'll need to continue to do that in the future. There's, of course, a lot of good examples. Years ago, the FCC held a workshop to develop technical and testing requirements for lighting devices. Who would know? LED lighting caused a lot of interference. Industry and government came together, and that was a success story. There's other success stories around boosters and repeaters, where, again, industry had come up with a consensus proposal and taken it to the FCC and was able to work hand in hand in instances like that. So I think some of those things that we've done before, policymakers should continue to leverage and just keeping those conversations going. I think one of the, as I had mentioned, EB issues advisories, I think those are very helpful to just act as a reminder of the rules of the road and recognize that those are helpful to a number of different, to all operators, and in particular, perhaps smaller operators that don't have so much resources to sort of digest all of this. It's really helpful to have those advisories. So I think overall, we need to have rules that provide predictability to licensees. That really enables operators to plan accordingly and their current and future development and deployment. And so I'm looking forward to the continued work in this area and continued discussion on this panel. And I will leave it at that for now and turn it back over to you.
Thank you, Anita. That's a lot to wrap our heads around. All the information you provided, that was very, very broad coverage, and really appreciate that. I guess since we have the opportunity here, the FCC has taken a policy leadership role in infrastructure protection associated with supply chain risk through the RIP and Replace program, as well as other activities. As you mentioned, Anita, the idea of the FCC with Bureau advisories, the CISRIC, and other types of activities and programs like that. Here to provide some comments, insights into some of the FCC activities is Charles Mathias. He's the Associate Bureau Chief in the Wireless Telecommunications Bureau at the FCC. And I'd like to turn it over to Charles to provide some comments for the audience we have here today. Thank you, Charles.
Great. Thank you, Drew. Can you all hear me? It's a pleasure to be here, and it's a privilege for me to be able to give you an overview of what the FCC has been doing in this area. While the FCC is an independent agency, it's a full partner in the government's efforts to secure our networks. And so what I'd like to do is walk you through the FCC's role, what we've been doing over the past several years, how that interplays with some of the executive orders and congressional action, and then tell you where we are today. So first, the FCC's role is defined by the Communications Act of 1934, and it includes, as one of the reasons for the FCC's creation, the purpose of the national defense and promoting safety of life and property through the use of wire and radio communications. The Commission assesses national security and foreign policy concerns in reviewing applications to transfer a spectrum license, a cable landing license, or telephone lines, among other things, when an applicant has a reportable foreign ownership. We work closely with other federal agencies that have additional expertise in these subject areas. And the FCC previously has denied an application from China Mobile upon the recommendation of executive branch agencies for international Section 214 authority to operate on national security and law enforcement grounds. As Drew mentioned, we have the CISRIC, the Communications Security Reliability and Interoperability Council, which is currently reviewing, among other things, mechanisms to best design and deploy 5G and networks to mitigate risks to network reliability and security posed by, among other things, vulnerable supply chains. Managing security risk in the transition to 5G and managing security risk in emerging 5G implementation. The action that we've taken began concretely in November 2019 in the report and order and further notice of proposed rulemaking. In this action, following an NPRM that was a notice for proposed rulemaking, which was issued in 2018, the Commission released a report and order adopting a new rule, which was 54.9. This provides that no universal service support may be used to purchase or obtain any equipment or services produced by or provided by a covered company posing a national security threat to the integrity of communications networks or to the communications supply chain. Specifically, USF recipients may not use USF funds to maintain, improve, modify, operate, manage, or otherwise support such equipment or services in any way, including upgrades to existing equipment and services. This new rule applies to eligible telecommunications carriers, or ETCs, and a covered company is a company designated by the FCC as posing a national security threat to the integrity of communications networks or communications, or the communications supply chain. The report and order initially designated Huawei and ZTE as covered companies for the purposes of the rule. What is the rule impact? It applies to any and all equipment or services, including software produced or provided by a covered company. USF recipients must be able to affirmatively demonstrate that they have not used any funds obtained by USF to purchase, obtain, maintain, improve, modify, or otherwise support any equipment or services. The prohibition applies to upgrades and maintenance of existing equipment and services because the item found that a blanket prohibition was the best way to promote national security. Vulnerabilities can be difficult to discover, as we've already discussed this morning, and malware can be designed and built directly into communications equipment. The rule does not prohibit USF recipients from using their own funds to purchase or obtain equipment or services from covered companies, but USF recipients must be able to clearly demonstrate that no USF funds were used. Existing multi-year contracts to acquire equipment or services from a covered company are not exempt from the rule, and ETCs must certify that they have complied with the rule. The designation process for future companies has a number of steps. First, the Commission will initially designate a company as posing a national security threat. Upon publication of the initial designation in the Federal Register, interested parties will have 30 days to comment on the initial designation. If no party opposes the designation, the Commission will issue a public notice following the 30-day window announcing a final designation. If a party opposes the designation, the Commission will review the record and release a final designation no later than 120 days after the release of the initial designation. The Commission may extend the deadline, but will endeavor not to do so in order to provide certainty to all impacted parties. The final determination will be based on all available evidence. On June 30th, 2020, the Federal Communications Commission's Public Safety and Homeland Security Bureau released orders formally designating Huawei Technology Company and ZTE and their parent subsidiaries and affiliates as companies that pose a national security threat. As a result of these designation orders, effective June 30th, 2020, funds from FCC's Universal Service Fund are no longer able to be used to purchase or maintain the equipment as I described earlier. The designation orders found specifically that Huawei and ZTE are highly susceptible to influence and coercion by the Chinese government and military. It found further that the Chinese government exercises strong control over commercial entities in its sphere of influence, and that China has a notorious reputation for persistent industrial espionage. Huawei and ZTE equipment also contains known security risks and vulnerabilities. The designation orders are informed by actions of the executive branch and other branches of the federal government, as well as similar assessments from other countries. The 2019 item also included an order requiring ETCs to respond to an information collection, and Carri will probably have a perspective on this. The goal of the information collection is to determine the extent to which potentially prohibited equipment exists in current networks and the costs associated with removing and replacing it. It was focused on Huawei and ZTE equipment and all equipment and services from these companies that are used by the ETCs and their affiliates. The information request seeks to answer certain questions, including, do carriers own the equipment? What is the equipment? What would the cost to purchase and install replacement be? And what would be the cost to remove? There was also a further notice, and I apologize for going through a litany, but I think it's important to sort of give you a sense of where we are, and this is also a window for those of you who are not familiar with it. This is the way the FCC works. There was a further notice that proposed to require as a condition on the receipt of any USF support that ETCs not use or agree to use communications equipment. They would be required to certify that to receive USF funds, and it would propose to require ETCs receiving USF support to remove and replace equipment from their services. It also significantly proposed to establish a reimbursement program to offset reasonable transition costs and proposed to make the requirement to remove covered equipment and services contingent on the availability of a funded reimbursement program. It proposed to make available reasonable replacement costs for equipment and services and proposed to seek a congressional appropriation rather than rely on current universal service funds. Now, as Jaisha mentioned earlier, the Secure and Trusted Communications Network Act of 2019 created a further role for the FCC. The act was signed into law in March of 2020, and Section 2 of the Act requires the Commission to publish by March 12, 2021, a list of covered communications and equipment services informed by determinations from either an intergovernmental agency with appropriate expertise, a specific determination made by the Department of Commerce, a list of covered equipment and services as pursuant to Section 889 of the 2019 National Defense Authorization Act, or a specific determination made by an appropriate national security agency. Section 3 requires the Commission to ban the use of any federal subsidy, as discussed before. Section 4 requires the Secure and Trusted Communications Network Reimbursement, creates the Secure and Trusted Network Reimbursement Program. And in April of this year, the Commission sought comment on incorporating the Secure and Trusted Communications Network Reimbursement Program into the FCC's ongoing supply chain proceeding. The rulemaking for this must be completed as well by March 12, 2021. Although Section 4 creates a reimbursement program, it's important to note that Congress has not yet appropriated the funding. Section 5 requires each provider of the advanced communication services to submit a report to the FCC on whether the agency has complied with the requirements. If the provider does not have equipment that's covered by the law, then they don't need to provide the certifications. If it does, they have to provide a detailed justification of what they have and why they're using it. Section 7 covers enforcement. Section 8 requires my colleagues at the NTIA, in consultation with the FCC, FBI, DHS, and others, to establish an information sharing program. And finally, we are getting to the end. In July of 2020, the FCC adopted the Secure Networks Act declaratory ruling and further notice to do what we had proposed, namely to integrate the provisions of the Secure Networks Act into the Commission's ongoing supply chain rulemaking. We found that by adopting the prohibition in 2019, we complied with Section 3 of the Secure Networks Act. We also sought comment on implementing various aspects of the Secure Networks Act, including proposals to maintain the list of covered equipment providers and services, a proposal that would prohibit the use of federal subsidies such as USF, a proposal to require all providers of advanced services to submit the annual reports, and a proposal to implement enforcement penalties. The comments and reply comments are due on August 31st and September 14th, respectively. So here ends the lesson. Thank you very much. I'm happy to answer questions as I can, but I would note that as this is an open proceeding, I might not be able to be as forthcoming as you might like.
Thank you very much, Charles, and thank you for your honesty presenting it that way. And we understand that there are constraints on what you're allowed to say. So as Charles kind of noted, the information around the Universal Service Fund, the Secure Networks Act, I think, now we're looking at the smaller carriers are facing significant hurdles as they move to deploy their own 5G networks, as well as some of the challenges being around supply chain risk and around some of the suppliers that have been identified as I guess we'll just say some of the suppliers that have been identified as problematic. So here to speak on the subject of the rural and small carriers, and specifically around their challenges and how they're addressing these 5G deployments, is Carri Bennett. Carri is the General Counsel to the Rural Wireless Association, and they represent rural telecommunications companies who each serve fewer than 100,000 subscribers. So Carri, if you'd like to take the mic.
Thank you, Drew. Hello, everyone. I want to follow on what Charles laid out so beautifully, and I don't have to talk as much because he laid it all out, but I'm going to tell you the real-world dilemma that these small carriers are in. About a fourth of the Rural Wireless Association members have deployed Huawei or ZTE in their networks, and I want to back up about 7 or 8, 9 years and explain why that's the case. Back in, I think 2010-11 or so, the FCC started a proceeding to disperse money called Mobility Fund Phase 1, and it was $300 million to help build out 3G and 4G in rural and remote areas where these carriers serve. So in trying to make the best use of that money, which is very limited, and it was done through a reverse auction where the lowest bidder got the money to serve a particular area, ZTE and Huawei had been in the United States trying to sell equipment and services, and they came in and undercut the market and made it very, very lucrative for the carriers to participate in these reverse auctions because they could get the equipment at severe discounts from what they would buy from the traditional carriers like Ericsson and Nokia. So that's how we got to where we are, and now we're there. And since they deployed 3G and 4G, none of them have deployed 5G, fortunately, and that's a good positive thing. But now we're in a predicament where things have changed or information has been learned, and we're trying to these companies are trying to figure out how they pay to get the equipment out of there. A lot of them are ETCs, the eligible telecommunications carriers that Charles mentioned that get universal service support. That support got cut off on July 1st to use anything to support the Huawei ZTE networks, maintain it. Some of the money can be used for other things that don't necessarily pertain to the network, but might pertain to customer service, backup generators, things like that are not purchased or used or from Huawei or ZTE. But going forward, since they can't spend universal service money under the Secure Networks Act on, I don't want to call it rip and replace, we like to call it replacing and removing, or replacing and removing the equipment, because you have to replace the equipment before you can remove it. Following the order, and I think I'll go back to last June when Commissioner Starks held a workshop called Find It, Fund It, Fix It. The FCC is in the process of still finding it through the data collection. The Secure Network Act is going to make us go beyond the scope of just ETCs that have to report in. There are a lot of ETCs that have also deployed Huawei or ZTE equipment that were not covered under the FCC's current data collection process, but will be under a new data collection process. So once we find it, then we still have to fund it. And Charles mentioned that we can't fund it with USF. We have to fund it through an appropriation from Congress. And that's what we're in the middle of, trying to get money appropriated for that now. On the Senate side with the COVID Relief Act, there was a provision in the McConnell Senate bill that was proposed to include funding under the COVID relief portion for up to $1 billion to fund this replacement. The House has already passed as part of the regular appropriations process for fiscal year 2021, which begins October 1st, $1 billion. Chairman Pai has indicated early on in April that it may be $2 billion that we need. Fortunately, the Secure Networks Act is not a blank checkbook, but the FCC has to move forward once they know the information and how much it's going to cost. They can come and ask Congress for more money in different years to be appropriated. It's a process that's not going to be done in a year. It's going to be, we're estimating a 3 to 5 year process to get the resources to do it. You have to remember Verizon, AT&T, and T-Mobile work, so they're using us and do the tower building and siting and all of that. So it's a little challenging to then try to get those resources put together for rural areas to do the replacement and removal of the equipment. RWA has been working very closely with the veterans who are being trained. There's a whole program called what's it called? The Warriors for Wireless, where they're taking veterans who have left the military and retraining them to help build out these networks. I think that's some things that maybe T-Mobile might be involved in as well. But we're trying to get resources so that we're ready when the money is appropriated. So there's a lot of challenges that the rural carriers are up against. The other thing that's interesting, because this is a 5G focused group, some of the equipment that we'll need and software to replace the 4G and 3G equipment already has 5G baked in, but there's some question before the FCC on whether you can use the money to buy 5G, because that's not what you're replacing, but it would make sense to buy some 5G and have a secure network with this money instead of going back to some old technology and replacing that. So that's something that we want to have further discussion on with the FC, the NTIA, and the administration. But we're all, I think, rowing in the same direction and working really, really hard to get this done really fast and to try to do the best with the least amount of money. But we don't want to repeat concerns that were brought up because we were being cost effective before and we ended up buying equipment we shouldn't have bought. So some of the challenges that our members have going forward, especially when they start looking at deployment of 5G, is we don't want to be in this situation again, and we'd like to shift the burden of the cost of any future replacement that Charles alluded to, because we don't know if there's going to be other equipment vendors or software providers that we'll have to remove later on down the road. RWA would like to see the burden shifted to those companies, so that if you buy equipment from companies and later you find out that they have problems, that the cost is shifted to them and not to the carrier. So that's going to require, I am a lawyer, making sure when you do your equipment contracts and your service contracts that you shift that burden to your supplier. And then the part that I think I want to have an off-site conversation with Jaisha Wray at NTIA is, these small carriers don't have the resources. The guy who's putting the antenna up on the tower is the guy cutting the grass, around the tower and doing the maintenance on the tower. And, he may also be the one that, is getting a cow away from something that the cow shouldn't be chewing on. So I'm just letting you know that, few resources, but very smart people out in rural America who make do with a little, and they make do very well, and they serve this country beautifully. So we want to continue to make sure that happens. We also, I just wanted to address one other thing besides the security issue on that side is one of the things that our members have said to us repeatedly is, why can't we monitor the networks? Why isn't there a better monitoring program? Because how do you stop something if you don't even know it's in there? And it seems like some resources should be placed more on monitoring as well going forward. And they would like to be able to take advantage of that if the government is willing to try to put those programs in place and push monitoring of networks further down the chain. So I'll leave it at that because I think we're going to have a lot of robust discussion, and I'd like to make time for that. So I'll turn it back to you, Drew.
Thanks, Carri. Much appreciated. So our final speaker for this morning, before we go into Q&A, is Mike Murphy. Mike is the CTO for Nokia North and South America. He's responsible for aligning Nokia's product roadmap with the needs of customers in the United States, Canada, and Latin America. Mike, we've opened this discussion with a broad coverage of 5G deployment security activities by carriers, government policies, unique challenges of the small rural wireless carriers. I love the comment that Carri made about monitoring the network and detection and what can be done in those areas. So as a provider of end-to-end 5G networks and services, what can you tell us about the security challenges of securing spectrum and these 5G deployments, and how can we continue to advance technologies to mitigate these threats? Mike?
Okay, thanks, Drew. If you don't mind, I'd like to start with kind of telescoping, start at the top level, then move down to more detail level. So at the top level, I guess our view is that 5G is inherently, on a path to being less secure in the sense that the attack surface is much greater. So in 4G, which was dominated by largely smartphones, we view 5G as extending into vertical industries. And what comes with that, as well as different areas, is potentially more catastrophic impacts of intrusion or bad actors. So, if you have a problem with your smartphone, it's not necessarily catastrophic, but if you have a problem with your electrical utility or robotic surgery, that's pretty catastrophic. So the attack, we say the attack surface is bigger. However, on the positive side, this was well known in advance, and so there's been many levels of improvement in the definition and also now in the execution of 5G. So standards are a lot better. As a vendor, we put a lot more emphasis into the product elements. Our customers are doing more on the network side. So there's a lot of improvement versus 4G. Despite all that, we still say that the final proof of trust is in the supply chain. You need to trust your suppliers. So, we agree with the FCC's stance on this. Now, getting a little more detail. So on 3GPP, the standards for 5G, it's done a great job. Things are a lot better than in 4G. A lot of the interfaces that weren't encrypted before are now encrypted. Some of the old problems like IMSI catching, those are close to impossible now. Even the fundamental architecture of 5G is better. You have things like CU-RU-DU split, which breaks up base station into multiple parts. Some of it, for example, the part that resides near the antenna doesn't even have any access to user info now, so you can kind of isolate that part. Splicing allows you to have virtual and even physical separation, so you can have different boxes that support a slice or a virtual part of the network. That gives you a physical protection. But despite all that, 5G is still vulnerable. There's still messages, there's still control channels that are not encrypted. But the good news there is that these are slowly starting to be addressed. So there's a standard, there's a document called TR 33.809. It's been going on for 2 years now, And it more or less lists out all of those problem areas that I mentioned, and step by step, there's going to be solutions to those. That being said, not everything can be solved. There's sometimes technical hurdles to execution of some of these solutions. Okay, good. Continuing on a different plane. So that was the standards plane. On the vendor plane, for example, a company like Nokia, at the very highest level, we put a lot of emphasis on ethics. There's mandatory training for every employee. I just finished mine a week ago. We're part of the Ethisphere subscription to looking at the world's most ethical companies. We're a 4-time honoree. I think we're the only telecom infrastructure vendor in that as a world's most ethical companies. We also involved in the NIST 5G security, FCC CISRIC, as you mentioned. But coming down to the product level, we have something called Design for Security, where we look at every single thing we make, hardware and software, from supply chain to software development, and we assess it for security threats. And that includes third-party software, by the way. So we look for things like hard-coded passwords, backdoors, and make sure those are removed before we deliver them to a customer. And we also have something what I think is quite interesting is even after you do all of that and you deploy networks, you're still going to have problems. So we have something called a threat intelligence lab that looks at over 70 networks worldwide. And a couple of interesting statistics there. So since COVID, the monthly rate of infections in the network has increased by 2 times. And since 2019, the infections by IoT devices has increased 2 times. So this is definitely a growing problem. And the last report we did said that the monthly average of infected devices in the US is about 2.3%. So if you calculate that out, that's about 700,000 infected devices today. And that's largely smartphones. There's some portion of that is IoT. But as we move towards 5G and the IoT side starts increasing dramatically, we would expect that to increase exponentially almost. And another interesting statistic is that from our threat intelligence lab, we observed that once an IoT device is connected to the network, it takes about 3 minutes before there's an attempt to infect it. So it's a big problem, but on the other hand, good things are happening to resolve some of the problems. Coming back to the more, one of the questions was asked for this session was about interference and jamming. So that's kind of inherent in anything that's RF because you can't block the airwaves. So once it's in the air, you can look at monitoring it, copying it, and repeating it. But there's a lot of things that are good in 5G to help against that. So, just at the very, very highest level, 5G is higher frequencies, which makes it, on the bad side, it makes outdoor to indoor penetration more difficult. On the positive side, if you really wanted a highly secure system indoors, you could use millimeter wave indoors, and the external propagation outwards would be fairly low. Also, beamforming is very directional. That makes replication more difficult. So there's some good things happening even on this interference jamming topic. So in short, we think 5G has more threats than 4G, but there's also more action that's been taken compared to 4G, and continuing action. So that's kind of my quick summary here. Now, Drew, you asked me, you said, hey, Mike, can you end on a controversial topic so we have some good dialogue here? So I'll try and do that. So my question, which I know will be controversial, is as we move to more open ecosystems and ORAN as a foundation for that, so we have more suppliers of different sizes, can't necessarily be consistent to do all some of the things I mentioned that Nokia does. Will that actually increase threats?
Oh, that's a doozy. Thank you very much, Mike. This is great discussion, great setup on the technical side of things, and a wonderful leading question. And I know that it's interesting because we have a lot of folks here who are dealing with the Open RAN and really open and interoperable networking configurations. And it's interesting because I'm of two minds of it. I understand the premise that by opening up and expanding the supply chain ecosystem to new entrants and to other entrants through opening up these different components within the network, that there's a theory that they can help the U.S. have more U.S. suppliers, U.S.-centric suppliers, and therefore that's going to improve supply chain risk management. I understand that argument. I also look at it from the standpoint that anytime you're opening up and adding more platforms and more interfaces, and you mentioned in terms of the 5G network, the idea of the CU, the DU, the RU, which is the radio unit, the distribution unit, and the control unit. And if I'm going to separate those three out and have different vendors, and I'm going to have different interfaces across those, every one of those interfaces becomes a new attack surface, right? That right now is pretty much enclosed within a more proprietary architecture. So you can see that on both sides, there's going to be arguments for and arguments against. So it's definitely a loaded question. So I think, my perspective is that a supply chain risk management, the idea of specific countries that are problematic and suppliers from specific countries that are problematic is a concern, but there are ways to manage that threat. And I think one of the things within the Department of Homeland Security Supply Chain Risk Management Task Force that I'm a member of, and Nokia is, as well as Verizon, as well as NTIA, et cetera, and FCC. So when I look at that, when we talked about some of these threats, and we evaluated somewhere, I actually co-chaired the Threat Evaluation Working Group. We went through and did a survey and got around 300, 400 some odd threats that we then categorized into different areas. And one of the things that we found is that to just say, well, if it's a foreign provider, that's a threat, that's not necessarily true. There's a lot of different criteria that you take a look at, and it's if the provider is subject to control by a nation state, and that nation state is a threat. That's where that threat really originates. So there's a lot of things that we have to be a little bit more mature about, and we are. I think from the public-private partnerships that we're having right now, we're getting a much better handle, I think, on both sides of the fence as far as supply chain risk management and how that feeds into the enhanced security and resilience of our moving forward networks. So that is one person's view of it. I'd like to open it up. Somebody wave if they're interested in adding to it what their views are on supply chain risk management and specifically around the radio side. Anybody? Yes, Anita, please.
Well, I agree with what you were just saying, Drew. I'll just add that, I think going back to my lessons learned, let's learn from the lessons of the past. So we've done this in the core already, right? And Mike, I would defer to you for the engineering analysis there. But learning from the lessons of the past and using those in the new context of ORAN. Open doesn't have to mean insecure. So let's make sure we're baking security in as we're doing that. I think the challenge is that there are challenges, right? There's the idea that you can open the marketplace, but this isn't the kind of thing that just anyone can do, as you well know. Like you need good engineering experts that are developing the software that goes into the boxes. This is not, it's like a colleague of mine said, it's like if Verizon were to open a restaurant, well, our Wi-Fi might be great, but our food might not be that great. So I think that's the challenge. And operators that are currently, in the deployment phases, it's a challenge because we need stuff now. And then not only you need it now, but then you also need. The deployment is a challenge. You have thousands, doing it in the US, right? You'd have to switch out thousands of boxes. And so there's challenges there. And then, of course, we could go into what are we all dealing with right now, COVID, and the ability to actually get boots on the ground to do that can be challenging. So I think, just as Drew was saying, the sort of open access arguments that you hear from sort of government side or sort of the economics of it should be weighed with enabling devices that are and software that's secure and deployable and So I think those are just some of the thoughts percolating on this.
Thank you. And actually, there was okay. Carri wants to weigh in on this. I also have a way I'm going to tie it in with one of the questions that have been raised. But Carri, you first, please.
No, I was just going to say from my members' perspective, because they're about to be in a position to have to deploy brand new networks. They're looking very hard at these open interfaces and open RAN radios and whatnot, because to them it's like, we get this money, we have to make, again, good use of it. They're very conscientious of this. They can use it to upgrade through software, and that would be really important. And so these deployments in these areas, I think, as long as this is secure, and our understanding is, and I'm a lawyer, I'm not a technical person, that the open interfaces, because they're open, you can see into it. They're not proprietary, they're not closed. You can't see the bad stuff that maybe you could see in what we suspect the government has suspected has been going on with Huawei and ZTE. So that to us is exciting, and to future-proof networks by being able to upgrade like that would be very, very important. So, and do it once, and then the lift going forward into 6G and 7G, which I'm hoping I'm retired by then, will be a much easier lift. So that's our comment from the roles perspective. So,
thank you. Any other comments and thoughts around the idea of these open networks and open interfaces? And if not, I'm going to actually try and tie this in a little bit to one of the questions that came in. Since we have been talking about this in the context of supply chain risk management, one of the questions that came in for Jaisha was around that the NTIA seems to be, or the administration, it was more of a political question, seems to be almost exclusively focused on supply chain risks. And the question was, what about all the other threats to the security and reliability of 5G networks? And I know NTIA has a lot going on in these, so I think it'd be great for you to kind of open up that conversation on it, please.
Sure thing. Thank you. No, and I see where that question came from. A lot of my remarks were focused on the supply chain aspects, and I think that is one of our key focuses, because we are recognizing that adversaries are trying to steal information, exploit these systems for intelligence collection and surveillance. And so what better way to stop it than by focusing on the supply chain? But of course, our 5G strategy is multifaceted beyond the supply chain. We are looking at enhancing U.S. participation, U.S. leadership in standards bodies. We are looking to promote R&D, testing, evaluation of new technologies. So I would encourage you to take a look at our 5G strategy, and the implementation plan, which is being developed now, will offer an even more comprehensive approach on the U.S. actions that we are taking to really face the threats to security, reliability of our 5G networks. But yes, a lot of it is focused on the supply chain.
Yeah, well, it's interesting because building on your comment and Carri's comment before about deployments, and Anita's comment about deployments now, what we have to do today, one of the things that I know we've fed back into, and a lot of the folks in the industry I talk about in our conversations with NTIA around the next generation and what the future research plans are. And to this community that's on the call here, you're probably going to find this also very interesting, because this is one of these research areas, is how do we start looking at those next generation 6G or next G whatever waveforms? How do we look at the different, if we start to look at terahertz frequencies, what are the different things we're going to be able to do there? And are there improvements now that we see what's happening in the 3G, 4G, and even in the 5G spectrum and spectrum efficiency, some of the benefits of beamforming, as Mike comment on, and things like that. Are there ways for us to look at that spectral protection and kind of build it into that next generation research for that next generation 6G and beyond? So, I mean, I'll just put that out there as a challenge to the audience, because I'm assuming there's a few academics out there who are looking at this problem, and we'd love to hear, and I'm sure NTIA would love to hear what you all are working on, because we're really would like to drive and this fundamental research that needs to be done for that next generation of technology, which is another way that we can actually have a U.S.-led and get back into the infrastructure lead that we've had in our country over the past decades for the 3G and 4G beyond. Okay, so that was one of the questions. I see that Jaisha would like to comment some more, and so would Anita.
One thing to add on that is I know Doug Kinkoff also thanks everyone who submitted comments on our request for comments on the National Strategy to Secure 5G Implementation Plan, but this was a topic we certainly heard about there. We really welcome feedback from all of our stakeholders and really encourage everyone to continue this discussion because, as Drew mentioned, this is a critical focus.
Thank you for that. And Anita, I saw your hand was raised. What would you like to add?
Well, I was just going to echo join the chorus there in terms of research. You guys at T-Mobile have a lot going on. We have a lot at Verizon in terms of lots of labs and opportunities for collaboration, businesses and universities and that sort of thing. And of course, I'll put a plug in for ITS and Andy. And the group, I think that that's where it's going to come from. And I was also going to mention on this question, other threats about security and reliability. I think we're seeing it in the government from other places too, right? So a lot of us are thinking about the upcoming cybersecurity maturity model coming out of DoD, and so clearly. That effort is a large one and is focused on more than just supply chain. It does include, of course, supply chain and references to NIST 800-161, but there are definitely broader efforts afoot. So just wanted to throw that out there.
Thank you, Anita. Thank you for bringing that up. One other area that and Mike, I want to kind of lean on you in this one, hopefully, and that has to do with both Anita and I mentioned the idea of dynamic spectrum sharing. You talked a little bit about it as well, but one of the questions that was raised is when we talk about enabling for the Gs and all of that, there's a little, the audience is saying that there's a bit of confusion about dynamic spectrum sharing in terms of how applicable it is for sharing in a non-exclusive spectrum environment. So the question has to do about can anyone elaborate on scalability of dynamic spectrum sharing for use in shared spectrum regimes? And I know Nokia has got a dynamic spectrum sharing platform product. Maybe you could talk a little bit about what it is, how it works, and what it is anticipated to achieve in this type of an environment. That would be very helpful, I think, for the audience.
Okay, well, I mean, dynamic spectrum sharing is a pretty simple concept. So you have two choices not to share, so not dynamic spectrum sharing. So then you basically have your 4G spectrum is used for 4G, 5G is used for 5G. In fact, the Sprint first deployments 5G were done using this, what we call split mode, 4G, 5G. Dynamic spectrum sharing is just saying, okay, I want to use some of that 4G for my 5G for 5G. However, I don't want to dedicate it because the fact is right now in the United States, you don't have that many 5G devices out there. So I don't want to give up 4G spectrum completely allocated to 5G where there's not many subscribers. So how can I do that in a dynamic way, basically based on request? So if there is somebody 5G device in that particular geographic area, that spectrum can be used for 5G, but if there isn't, it's used for 4G. So it's kind of a way of smoothly transitioning from 4G to 5G. So it's very, very important, especially in the United States where 4G capacity is kind of at its maximum. So it's not like you can just steal away spectrum and hand it over to 5G. You still have the subscribers needing it. So this is an elegant way of doing that. Does that answer your question?
Thank you. Anita, you wanted to weigh in on this as well, please? You're on mute, Anita.
Sorry, can you hear me now? To quote an old commercial. So I agreed. And I think from a policy perspective, I think there's challenges, right? Like, so the technology may be there, but then in my mind, I wonder, how is this, this question is asking about a non-exclusive spectrum environment. I have a question around, well, what about when we're talking about government and industry sharing? What does that look like? And, I think that there are challenges there aren't rules in the road yet for, well, who gets prioritization? Like, okay, well, if I'm doing it for If an operator A is doing it for operator A's customers, then operator A has full control over where and how much, and the movement, the dynamic use and efficient use, and can monitor that, and all of those things that come along with spectrum management. So, but then how do you do that when you're introducing a couple of carrier A and carrier B, or introducing carrier A DoD, or that's where I think we need some good dialogue and good industry, not to sound too repetitive, but that collaboration between government and industry. Get that right, otherwise it won't be able to be used as well as it could be. So.
Okay, thank you, Anita. And Mike, I see that you've got an additional comment you'd like to raise, or is it another inflammatory question? Just kidding. So go ahead and unmute Mike. Mike's yours.
Very specific technology, but there's something completely different, which is just sharing spectrum like CBRS. And going forward, we know that a lot of spectrum is still used by agencies and is difficult to free up easily. So then we have to get into a shared spectrum, something like CBRS. And it is true, it can get a bit tricky depending on the particular usage of it. So in CBRS, we know it's used by radar on coastal lines, of course. And I was talking with my colleagues, there's something in CBRS called the ESC, Environmental Sensing Capability. Basically tries to detect radar. If radar is on, it switches you off. But on the other hand, it's actually pretty easy to probably replicate such a signal and basically turn the operators off. So certainly, I think the broader context of sharing between different parties, whether they be different operators or government agencies, commercial business, big topic, and it brings with it more questions about how do you make it secure.
That's from our perspective, one of the concerns we have raised is if I'm running commercial traffic and there are other providers, radar, for example, or other types of devices in there, now the idea of a rogue base station goes out the window. Because if it's in a shared spectrum, anybody can be in that spectrum, whether they are legitimate or whether they're nefarious. And so it changes the dynamic tremendously. And this is not a simple problem, and it's going to be with us for a while as we try to figure it out collectively. And I think that's an important thing to note in that regard. Carri, one of the questions that came up, I want to direct to you, is the question was about the RWA members and any potential impacts or experiences they've had related to security vulnerabilities in the existing Chinese equipment. To what extent has existing equipment proven to be insecure, caused any outages, breaches, malware, espionage, hacking? In other words, really, has there been any that you're aware of? You don't have to name names, obviously, since your association is good. But have there been any instantiations of these threats, vulnerabilities, in a material way or even in a non-material way that you're aware of within the rural community?
Flat out no. That's why, in the beginning, I think there was some reticence on all of this when this first, launched. But, they understand that they trust the government, that there is problems, and they're ready to move it and get it out.
Okay. Short, asked and answered. So another question came up, and I'm going to just open this up for the broader community here, is that it has to say, we talked about 5G supply chain security. They were talking about, has any thought been given to the unknown unknowns in 5G security, supply chain security, which I think is a kind of an interesting way of asking it. And my initial perspective on this would be from the standpoint that the Supply Chain Risk Management Task Force did look at these 300 some odd, categorized them into 9 broad categories as far as the types of supply chain risk management. So they weren't just about a supplier actually intentionally putting things in, but we incorporated economic threats, we incorporated insider threats, we incorporated a broad spectrum of threats in that, and that is something that has been published at Department of Homeland Security, Cybersecurity Information Security Agency's website, and you can dig that up. I could also share it with folks who organize this Andy and team to get it published out so you all can get access to it. It probably answers that question fairly clearly about, yes, the thought has been given, and industry and government have worked together in that particular one to address some of those challenges and concerns about supply chain security. Let's see here. Just want to make sure we got. One of the other questions was raised up about end-to-end the 889 guidance from the federal within the National Defense Authorization Act, and some of the guidance there concerning integration or use of telecommunications equipment and services from prohibited providers. Along those lines, one of the question that was raised, and there were variations of it, but I'll just kind of drive into one aspect of it, which is the idea of interoperability between North American operators that are covered by this and international operators, because we do have roaming scenarios where a foreign person comes to the U.S. and is roaming in the U.S., and we have to interconnect with their home operator, and vice versa, where a U.S. person goes to that foreign. And the general concern or question was, how do we ensure that there's, I don't know, I guess the idea of protecting, and does the 889 restrictions actually apply to this type of a scenario? So we've got a couple people here who've got a legal background. I'm not one of them, and this would seem to me to be more of a legal. So we'll start with Carri, who's got her hand raised, and I'd like to, if any of y'all would like to add into it, I'd love to have, y'all participate.
Well,
Carri?
I was going to say, after the NDA 2019 was passed, I think Congress, or some members of Congress, immediately realized what they had done, and that it did cause a problem with our foreign service offices overseas, our military bases, and the government contracts, that those Huawei networks and ZTE networks are deployed in different parts of the world, and there's not a way to not be on them. So I think that initially caused some problems and immediate violations. I don't know what they did to fix it or take care of how to deal with it. I just know that they identified it as a problem.
Thank you. Charles, if you could add some context for it, that would be very helpful. Much appreciated. You're on mute, Charles. Charles? Yeah, thanks.
Thank you. The precise interpretation of 889 is a DoD. It's sort of arcane, and I don't know the precise answer for that, but a related question that I saw was, what would happen if you had international networks and you had prohibited equipment outside the U.S. and you got USF money? And I can tell you, and Carri would have a perspective on how many of her members, because I think that might be the group that would be most impacted by this. The way I think we would interpret it, if you have prohibited equipment and you bought it and put it overseas, that would be a problem for us. But we're really concerned with just the network that you're responsible for. And if you have to interconnect internationally, that's not something that we're looking at. We have a narrow approach.
And I would just follow up and say that my members aren't doing anything overseas. I mean, they don't deploy anything overseas. But I think what the concern is like, if you have a government contract and you're using Verizon or T-Mobile or AT&T, one of the bigger carriers, and you have to take these phones, or you're serving the military bases overseas, or the diplomats overseas, and they have the contract with Verizon or AT&T or T-Mobile, and then they're interconnecting with these networks, then how do you stop that from happening? And I think that's the part that I think is about to go into effect tomorrow. And that's where that interim rule is coming through. And I think that could be problematic. But I think it went into effect for that purpose, like almost immediately. And then they realized after they passed the law, like, oh, we just put ourselves in violation of the law. And I don't know what happened. I was told that by members of Congress, and I never knew what the resolution was because it's outside the scope of what I do. But that's where it is. I think it's the government contracting aspect. And I think the other problem is from the rural carriers' perspective, a lot of these rural carriers who have these networks in place are along the borders of, Canada, and Canada has Huawei equipment deployed, and there's roaming that goes back and forth between the Huawei networks on this side of our side of the border and on the Canadian side of the border. So it's problematic in that there's a carve out for roaming on third-party roaming that is in there, but where we're finding a big problem is the way it's being interpreted under the interim rule is that if Verizon is roaming, letting its federal government folks roam on these third-party networks that are my company's networks, then that's okay. That's covered under the exemption. But there might be an interpretation that they can't let their own customers, Verizon's own customers that are not federal customers, roam on this network.
And with that,
that's where we have an issue, I think.
I think Andy's pulling out the hook.
Okay, sorry. It's very complicated.
I'm going to get my gong show hook and reel us back in.
Andy, real quick, I hate to interrupt, but would you also mention to folks, we're going to provide documentation, things like that, some of the things we've mentioned. There have been some questions about that, so if you'd address that, please.
Right, yeah. So for everybody out there, I know that a lot of the references that Drew mentioned, we knew coming into this that there was going to be interest in following up on those, and so we will work on making sure that those references, to all the documentation that we talked about today is posted. So with that, the transition now, and so I think this is a good segue into the Q&A that you'll have with each one of the panel members and Professor Zajic as well. So let's see. I have to read my part here. We're now going to go into the breakout room. Remember, the information on the breakout rooms is in the ISART app or on the email that you got for confirmation. And for our panelists, remember to close this and then re-click on the link to jump into your breakout room so we don't get any crosstalk between the panel session and the breakout room. So with that, I look forward to seeing you each in the breakout rooms. Thank you.